Okay, so we are still doing Chapter 2 example problems, and we are still using the equations of motion with constant acceleration, and we are still working on what I did when I was driving my car. So another thing that I did when I was driving my car was I got into my car and I drove till I got up to a speed of 30 miles per hour. Now hit pause and figure out what that is in terms of meters per second. 30 miles per hour in terms of meter per second. Hit pause, go. Okay, what I need to do is I need to do 30 divided by 2.24, and I'm going to come up with 13.39, I'm going to say 13.4 meters per second. So I got into my car and I was driving at 30 miles per hour, which is 13.4 meters per second. And then what I did is I slammed on the brakes and I timed how long it took for me to come to a complete stop. Hit pause and fill out something you can on that chart based on the fact that I measured the time and I came to a complete stop. Okay, what you should have filled out is you should have said VF is 0 meters per second because I came to a complete stop. Okay, now I did measure the time. I measured the time on my trusty stopwatch, and the time that I measured was 2.2 seconds. Well, let's rapidly as we can figure out X and A for this problem. Well, first thing, let's figure out A, and you tell me what equation we're going to use for A. The equation that you should have come up with is, since we don't care about X, you should have come up with A is equal to VF minus VI over T. So A is going to be my VF, which is 0 meters per second. My VI is going to be 13.4 meters per second. And my time is going to be 2.2 seconds. So my A, I don't need to do the 0 minus. I can just hit this button down here, minus 13.4 divided by 2.2. I come up with -6 meters per second squared. Now, if we go back and we look at my acceleration problem from the last video, I figured out that my acceleration from the last video, going from 20 miles per hour to 40 miles per hour at a reasonable, just like not squealing the tires pace, was 3/4 of a second. Oh, I'm sorry, 0.74 meters per second squared. 0.74 meters per second squared. And now, here, I went from 30 to 0 as quick as I could. And from 30 to 0 as quick as I could took me 6 meters per second squared of acceleration. So much, much more. More than 8 times more. What does this negative mean? This negative means that I was accelerating backwards. And we'll have to think about this in a second, but the negative means that I was accelerating backwards. It does not mean that I was slowing down. Since I was already moving forwards and I was accelerating backwards, that became the reason why I slowed down. But if I had been stationary and I threw the car into reverse, my acceleration still would have been negative. How do I know I was accelerating backwards? Well, because I felt that the seatbelt was pushing me backwards. As I slammed on the brakes, I felt the seatbelt pushing me backwards, which meant that the whole car and myself was accelerating backwards at -6 meters per second squared. Let's put that up there. Now, I want to calculate x. So, find your equations and choose the equation that we're going to use to solve for x. Alright, if you chose x equals Vf plus Vi divided by 2 times t, you are thinking the way that I'm thinking. The reason why I chose that one is because we don't really know A. We could have made a mistake on A. So these are the three pieces of information that we have. We do not care about A. That leads us to this equation. Okay, x equals V final is 0 meters per second. My Vi is going to be 13.4 meters per second. We divide that by 2. We multiply it by 2.2 seconds. And do it on your calculator. Get out your calculator. Don't wait for me to just do it for you. Don't wait for other people to do it for you. Do it yourself. Okay. 13.4 divided by 2 times 2.2 gives me 14.74 meters. I'm going to call it 15 meters. X is approximately 15 meters. Okay, so what that means is I'm cruising down a dirt road in Vermont. I am going 30 miles per hour, which is 13.4 meters per second, because the way I get there is I take 30 divided by 2.24. Now, suddenly I see a moose. So, I slam on the brakes as hard as I can. It's going to take me about 2.2 seconds to stop, and it's going to take me about 15 meters to stop. So, I am hoping that that moose is further down the road than 15 meters, because if it's closer to me than 15 meters when I slam on those brakes, at some point in time I'm going to be running into that moose. Alright, that is that example problem for this video.